Welcome guys to my YouTube channel, right? And today we'll be doing permutation combination for the mathematics analysis and approaches HL syllabus, right? And so when we talk about permutation, we typically talk about arrangements, and when we talk about arrangement, that's when order matters. And combinations is just when order does not matter, right? And let's go straight into it, right? So when we talk about permutations, we talk about the number of ways to arrange something and number of times. And so typically it's how many ways of arranging R items given N items, and the typical formula is just N, P, R, and just put it on your calculator, right? And there's also another way of solving permutation questions, and it's when you draw the slots. So it looks something like this. So N minus 1, N minus 2, N minus 3, and so on. And this is just R slots, right? And this is actually just called counting principles. And you'll see that when you do like the revision village questions on permutation and combination, is called counting principles, right? So although you guys like it might seem confusing right now, but I think hopefully when we do the examples, you guys will start to get the gist of it, right? And so let's go straight into the examples for permutations, right? So here we have 5 math books, 3 science books, and 4 language books. How many ways to arrange the books? So we just do 5 plus 3 plus 4. There's 12 books, so 12 factorial to get 12 possible answers, right? And so how many ways if the books needs to be arranged by subject? Okay, this is kind of tricky here, and the key to solving this question is you need to group each book. And like a good way to view it is like you have like one book and then you have several volumes inside, right? So you have the math book, and then you have volume 1, volume 2, volume 3, volume 4, volume 5. And so it just looks something like this, right? So 1, 2, 3, 4, 5. So this is for maths. And this is for science. 1, 2, 3, science. And this is for languages. 1, 2, 3, 4. And so in between these 5 math books, they're interchangeable. So so this is volume 5, right? So volume 5 could be in the volume 1 position, and volume 1 can be in volume 3 position, right? So that's why you do 5 factorial times the same here for the science, 3 factorial, times exactly same for language, 4 factorial, right? And you multiply everything here by 3 factorial, right? Because these 3 books essentially, like these 3 main books essentially can switch places. So math can be in the middle, or math can be at the other end, and science can be in the first position, or science can be in the last position, right? So that's your answer, 5 factorial times 3 factorial times 4 factorial times 3 factorial. That's your final answer. And part C is number of ways if maths has to be kept on each end. And typically for this one, I like to draw it, right, to just visualize. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so it doesn't really matter where you start, but so at the first position we have 5 possible math books to choose from to start with, and the last position we only have 4 possible math books to choose from because we already chose one of the 5 here, and so we're left with 4. And the middle, there's 10 books left, so it's just 10 factorial. So answer is just 5 times 10 factorial times 4. Alright? And that's your answer. And so let's go on to example 2. And in example 2, you have a string of numbers, right? So you have 0, 1, 2, 3, 4, 5, 6, 7, and 8. So that's 9 numbers. And so part A reads how many number of 3-digit numbers possible without repetition. And typically when you talk about typically when you talk about 3-digit numbers, we cannot really start with a 0. So we can only choose from these. So we can only start from these 8 digits, right? So 8, and then once we choose from these 8 digits, we're left with 7 digits, but we can use 0 in the middle. So we have 8 and then 7 at the end. So it's just 8 times 8 times 7. And now we have to do number of 3 digits which are greater than 400, right? And this is really easy again, because for it to be greater than 400, it cannot start with 0, 1, 2, or 3. So it has to start with 4, 5, 6, 7, and 8. So there's only 5 possible ways it can start with. And then, again, once we choose from here, we're left with 8 numbers left, right? And then 7, because we chose one number here, so we only have 8 out of the 9, and then we chose another, so then we only have 7 out of the 9, because we already chose 2 at the first start. Part C reads number of 3-digit numbers which are greater than 400 and even. Well, this is actually tricky. You have to do cases here. So case 1 is when it starts with 4, 6, and 8. And why we do 4, 6, and 8 is because we want to control variable, right? And that is because when we look at our string of digits, we try to look at, so for a number to be even, it has to end in an even number, right? So 0, 4, 2, 4, 6, and 8, right? But like if we just randomize it, like a number can start with 4 and it can also end in 4, right? But we don't want that because we want no repetition at all. So we want like a control variable. So either you control the first number or the last number. But in this case, it's easier because it has to be greater than 400. So it's easier to control the first number. So we start with all the evens to start with. So 4, 6, and 8. So we have 3 possibilities to start with. And then we have 7 possibilities, right? Let's just leave the middle blank for now. And so we have 3 possibilities to start with, and in the end, it has to be even. For a 3-digit number to be even, the last number has to be even, right? So how can it be even? So if out of 4, 6, and 8, let's say for this example, 4, 6, and 8, we chose 6, right? So we have 0, 2, 4, and 8 left to choose from. So it becomes 4. And then, so we chose one number here and one number in the last position. We only have 7 numbers to choose from in the middle position. And case 2, it's just starting with 5 and 7. So 2, 7, and 5. And why it's 5 at the end? Because it can end with 0, 2, 4, 6, and 8. So your answer is just 3 times 7 times 4 plus 2 times 7 times 5. Right. And now let's go into combinations. So for combinations, it's actually really simple. Combinations is really just calculator work where you just have to use the NCR formula, right? And for the NCR formula, we'll be just pronouncing it as 10, or like N choose R, right? So, example 1, there are 5 boys and 10 girls. How many ways of choosing 8 students? So 5 plus 10, that's 15. 15 choose 8 because it's NCR, so number of total, and we're choosing how many from that total number of people. We're choosing only 8, so your answer is just 15 choose 8. Part B is how many ways of choosing more girls than boys. And typically for these questions, you always want to do cases. It just helps you visualize. So case 1 is it's all girls, right? So all girls, and you just get 10 choose 8. Case 2, it's 7 girls, 1 boy. Right, so 10 choose 7 times 5 choose 1. Case 3 is 6 girls, 2 boys. 10 choose 6 times 5 choose 2. Sorry. And finally, in case 4, we have 5 girls, 3 boys. And we get 10 choose 5 times 5 choose 3. And now the final answer is just everything added up. So 10 choose 8 plus 10 choose 7 times 5 choose 1 plus 10 choose 6 times 5 choose 2 plus 10 choose 5 times 5 choose 3. Right? So it's just the addition of all of this. Right? Part C reads, how many ways can a team of 8 be selected from these 5 boys and 10 girls, so apparently there's a couple, where husband and wife cannot be separated, right? And so for this question, it's really simple, where we just do, again, 2 cases. So husband and wife are included in the team, right? So either husband and wife are on the team or they're not on the team, right? Because they just cannot be separated. So it can't be that the husband's on the team and the wife's not on the team, right? So they both have to either be on the team or they're off the team. So because they're both on the team in this case, we only have 13 people to choose from, right? Because there's only 4 boys left and 9 girls left to choose from. So 4 plus 9 is 13. And it's 13 choose 6 because we know that husband and wife are on the team. So out of the 8, we only need to choose 6 left. And so case 2 is just husband and wife are not included. So they're excluded, right? And so this is just 13 choose 8. Again, it's 13 and not 15 because we cannot choose from husband and wife, so we have to minus the 2 out, and we just choose 8 from those 13 that are left that are not husband and wife. Part D is how many ways can the team be selected, if husband and wife must be on the team but not both. Well, this is just the contrary of C, right? And so we have to get a control variable. And so for this case, we just do husband, right? So the husband is on the team, so it's just 13 choose 7. Again, it's 13 and not 14 because the husband is on the team, so we cannot choose from the wife. So if it were to be 14, that means there's a possibility that the wife we're choosing from, that there's a possibility that we would choose the wife to be on the team, right? And it's 7 because we know the husband's on the team, so one place is gone, so it's 7 instead of 8. And husband is out, and it's 13 again, choose 7, is because, again, so we know that the wife is in this time, so we can't choose from the husband, so it can't be 14, and it's 7 again because there's only 7 spots left. So just add these two, and again here we also add these two up. Right. So now let's just look at, so these are, so what we just did, like the example we just looked at were like the fundamentals of permutation combinations. So now let's look at some past exam questions on permutation combinations. Right. And so the first one is, we have 5 boys and 10 girls, and no boys sit next to each other. Right. So this question has to be approached in 2 steps. So step 1 is to arrange the girls. And to do this, so we know that there's only 10 girls, so it's just 10 factorial, right? But we want to visualize it, right? So to represent the girls, we'll be using like these straight lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so step 2 is to place the boys, right? And so there's only 5 boys, right? And no boys can sit next to each other. So they have to be in between the girls, right? So they have to be separated by the girls, right? And so for this, we'll be representing the boys by arrows. So a boy can sit here, a boy can sit here, because boy, girl, can sit here, a boy can sit here, a boy can sit here, and just goes on like this, like it's in between, right? And that's when we come to step 2, where we arrange the boys, right? And so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 possible places the guys can be in, right? So it's 11 P5, right? Why 5? Because there's only 5 boys. So out of the 11 places that the 5 boys can be in, only 5, sorry. So there are 11 places and only 5 boys can be put in the 11 places. So we just do 11 P5, right? And the answer is just 10 factorial times 11 P5. Moving on, so this is another really typical exam question. I think those of you who've done already a few permutation combination questions, you've probably seen a question like this where we're in a classroom setting and we have like 2 students where they're typically known to be cheaters, right? And so the question reads, Amber and Nikki tend to cheat. They have to sit one behind the other. How many ways can we arrange the 12 students, right? So in this question, we know that Amber and Nikki tend to cheat, and they have to sit one behind the other. And this means that, so they have to sit like this. So Amber can be here and Nikki can be here, or Nikki can be here and Amber can be here. That's one way. 2, 3, 4, 5, 6, 7, 8. So that's 8 ways that they can sit. So 8 times 2, right? 2 factorial or 2, right? Because 2 factorial is simply 2. And why 2? So I just showed you that there's 8 possible ways that Nikki and Amber can sit, right? And so out of these 8 ways, so Amber can be here and Nikki can be here, or Nikki can be here and Amber can be here. That's why I multiplied by 2. And we do all of that times 10 factorial, right? Because let's say, for example, Amber sits here and Nikki sits here, but so the 10 other students can sit anywhere else they want, so it's just 10 factorial. That's our answer. Part B reads, how many ways if Nikki and Amber cannot sit next to each other? Right, and so when we look at next to each other, it's like this. So, right, so Nikki can be here and Amber can be here, right? But we don't want this, so we just do, so this is one way they can sit. 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 possible ways. Again, so it's just 9 times 2, right? And so again, it's the same principle where it's like so let's say Amber and Nikki sits like this, where do the others can sit? Anywhere else they want, so it's just 10 factorial. And here's where it's tricky, because if we read in the first question, how many ways can we arrange the 12 students, right? And then it says, how many ways if Nikki and Amber cannot sit next to each other, right? And here we just multiplied everything because it was straightforward, right? But here, it's a little trickier, where in the sense that here we found the number of ways that occurs when they sit next to each other, but we don't want when they sit next to each other. We want when they don't sit next to each other, right? So then we just have to do maximum number of possibilities, which is 12 factorial minus this answer. But now you guys must be asking, how come we didn't do that for part A? Well, in part A, we're just asking how many ways. So we already know that they have to sit one behind the other, and so we're just asking how many ways they can arrange the 12 students, right? But in part B, it just says that, well, how many ways if Nikki and Amber cannot sit next to each other? So we have to do the possibilities of them sitting together, and then we minus it from total possibilities, right? And now let's go on to the final question, where it's where it's like another, where we're gonna have a string of numbers, right? So let's just read the question. A set of positive integers 1, 2, 3, 4, 5, 6, 7, and 8 is used to form a pack of 9 cards. Each card displays one positive integer without repetition from the set. Grace wishes to select 4 cards at random from. So once we see select, we understand that's combination instead of permutation. Select 4 cards at random from this pack of 9 cards. Part A. Find the number of selections, again, combinations, Grace could make if the largest integer drawn among the 4 cards is either a 5, 6, or a 7. Right. So we have to review cases. So we go case 1. So this is part A. So case 1, right? And case 1, 5 is drawn. And why are we doing this? Because it says that find the number of selections Grace can make if the largest integer is a 5, right? So the largest integer is a 5, right? So if we just pick 5, ooh, so if we pick 5, we can only pick 1, 2, 3, and 4. So we go, so we know 5 is taken, so we just take 4, choose 3. And why 4, choose 3? Because we only can choose 1, 2, 3, and 4. We can only choose from these 4 digits to get the other 3 digits. And case 2 is when 6 is drawn. And again, but this time 6 is drawn, so we know that we can only choose from 5 cards, so 5 choose 3. And case 3 is when 7 is drawn, and again, now 7 is taken, so we can only pick from 1, 2, 3, 4, 5, and 6, so it's just 6 choose 3. And your final answer is just the summation of these 3, right? If it was just 4 choose 3 plus 5 choose 3 plus 6 choose 3, and that's your final answer. And part B, it's find the number of selections Grace can make if at least 2 of the 4 integers drawn are even, right? So when we say if at least 2, so it can be two of the integers drawn are even, or 3, or even all 4 of the integers drawn are even, right? So we have to do cases again. So case 1 is when the 2 cards drawn are even. So we do 4 choose 2 times 5 choose 2. And where do we get 4 from? Is because 2, 4, 6, and 8 are even. So we do 4 choose 2 times 5 choose 2 to get the 4 cards. And then case 2 is when 3 are even. So we get 4 choose 3 times 5 choose 1. And then case 3 is when all the 4 selected cards are even. So it's just 4 choose 4. Right, and that's your answer. So you just add 4 choose 2 plus 5 choose, 4 choose 2 times 5 choose 2 plus 4 choose 3 times 5 choose 1 plus 4 choose 4. Right. And that's about it for all you need to know for permutations and combinations for the IB syllabus of MAAHL. Right. And I hope this video was super helpful to you guys, and let me know in the comments down below if you guys would like me to cover other topics, or if you guys had any questions or doubts about this topic. Thank you.